The next objective in this section is to solve compound linear inequalities. These types of inequalities are joined by the word and or. So as an example, suppose that X represents the glucose level measured from a fasting blood sugar test. You have a normal range and an abnormal range. They say a normal range on the glucose test is given by your score X is greater than or equal to 70, okay? And X could be less than or equal to 100. And so basically what this means is that it's somewhere between and including 70 and 100. So if your score is somewhere in there, you are in the normal glucose range. An abnormal glucose range is either below a 70 or above 100. So if you're outside the range on either the high end or the low end, that's an abnormal glucose level. So these statements are compound inequalities. There's one. Here's another compound inequality with an or. Now, one thing you need to know and kind of follow these guidelines is that if you see the word and, okay, know that both inequalities must be satisfied. Okay? If you see the word or, think about how you can be in either this range or this range to be labeled an abnormal glucose level. Let's look at the guidelines to solving a compound inequality. First of all, do a little bit of algebra to solve the individual inequalities. Now, if the two inequalities are joined by the word and, then the solutions are the values of the variable that simultaneously satisfy both inequalities. Okay, we're going to take the intersection of the individual solution sets, and it has to be in both. On the flip side of that, if the two inequalities are joined by the word or, then the solutions are going to be in either of those two equalities. Okay? On example 3, here we have one that has the word or in between those. First order of business here is to solve each inequality for n. On the first inequality, n minus 6 is greater than 1. To solve for n, I just need to add 6 to both sides. I really kind of want to do this in a different color. I want to get my stuff color-coded. Y'all know how I am. Okay, so I'm going to add 6 to both sides. And so n is going to be greater than 7. Bring down that important word in there, or, and now do a little bit of algebra to solve the other one. Okay? To get the 3/4 off of being multiplied by n, I can divide both sides by 3/4. Yeah, I'd rather not. I'd rather multiply both sides by 4/3. That way on the left-hand side, the 4's will reduce, the 3's will reduce, just leaving me with n. Bring down that greater than or equal to, because you did multiply both sides, but it was by a positive, so that symbol does remain greater than or equal to. Let's see, 6 times 4/3 is 24 divided by 3, or 8, right? 6 over 1 times 4 over 3 is 24 over 3, 8. That's how I got the 8. All right, now, to organize our information, I personally like to draw some simultaneous number lines. Okay, that means I'm going to draw one number line right on top of another number line. And I need to put 7 and 8 on these number lines, okay? So 7 is smaller than 8, and then, you know, over here we'd have 9, 10, 11, so forth. Okay, on the top number line, I'm going to graph n is greater than 7. The values of n that are greater than 7 are the ones that are bigger than 7. They lie to the right of 7. And I'm going to put a parenthesis at 7 because it just said greater than. On the bottom number line, I'm going to graph n is greater than or equal to 8. The values of n that are bigger than 8 lie to the right of 8. And this time I'm going to put a bracket at 8 because it said greater than or equal to. And the bracket's like a big old hug just saying, get in here, guy, you get to be included. Okay, I don't know. So anyway, now how we're going to deal with the compound portion of this, all right, is we are going to, in our final solution set, since this said or, our final solution set is going to consist of values that are shaded in either the blue or the green. That would be all of these and on. That's in either one of those. And then, should we put a parenthesis or a bracket at 7? Well, 7's not included in the blue graph, nor is it down here in the bottom graph, so I'll put a big old parenthesis right there. Okay? So for our final answer, it didn't really say if they want us to write it in set builder notation or inequality. You could say for the set builder notation, the set of all values of n such that n is greater than 7. That'll work. That's set builder. Or in interval notation, read your number line from left to right, and the first thing we're going to hit is that parenthesis at 7, comma, and then values that are huge will also satisfy that compound inequality. Now, on the flip side of that, let's look at one where we have the word and in there. All right? So keep in mind that our key word in here is and, but we're going to do a little bit of algebra to solve each of these inequalities. All right, so first of all, I'm going to get rid of the negative 4/5 that's being multiplied by m. I'm going to, that a is right in my way, I'm going to multiply both sides by negative 5/4. It's reciprocal. Let me squeeze that in right here. Negative 5/4. Woo! Okay? Now, over on the left-hand side, everything reduces, leaving me with m. Now, what you did right here is you multiplied both sides by a negative. So that less than symbol in our problem here is now going to swap around and become a greater than, because I multiplied by a negative. And let's see, what is 8 times a negative 5/4? That is negative 40 for the top, 4 for the bottom, so that's negative 10. So m values are greater than 10, and they also have to be, here to solve for m, on this other inequality, m is sitting right over here, so I'm going to divide both sides by 0.34. Divided by 0.34. So what we have from this is, let me see what, 0.85 divided by 0.34 is it 2.5? Yeah, 2.5. Okay? So I have 2.5 is less than or equal to m. You know, I really like it where, you know, I have m on this side. Now, if you swap sides of an inequality, you also have to swap the inequality symbol around. So 2.5 is less than or equal to m is equivalent to m is greater than 2.5. Okay? Again, let's organize our thoughts by putting these on a simultaneous number line. Okay, on the number line, I need the value of negative 10. Ooh, that's little bitty. That's over here. And then I also need 2.5. So if I want to write 0 maybe on my number line, about here, I'm just eyeballing it, would be positive 2.5. Now, for my first graph, I'm going to graph m values that are greater than negative 10. Those are values of m that lie to the right of negative 10. and I put a parenthesis at negative 10 because I just had a greater than. All right, for the green inequalities graph, M values are greater than or equal to 2.5. There's the values that are greater than 2.5. Because it said or equal to, I'm putting a bracket there at 2.5. Okay? Now, taking into account the fact that this was a compound inequality with the word and in there, that means that it has to be, for it to be in my final solution set, it has to be in both of these graphs. Now that is only values of x that are greater than 2.5 and on. And the question now is, should I put a parenthesis or a bracket at 2.5? 2.5, because of the bracket down here, is actually included. And 2.5 is included above, and it has to be in both for it to be included. So it would be included in my final solution set. So bracket 2.5 to infinity. That's my solution set written in interval notation. In set builder notation, the set of all m values such that m is greater than or equal to 2.5 is the set builder notation for my solution set.